Welcome back to day 8 of DSA in Rust. Yesterday we ground through easy array problems, and I bet you wrote at least one nested loop solution that felt slow. Today we fix that. Two pointers is a technique that replaces O of n squared pair searches with a single O of n pass. It shows up constantly in interviews, and in Rust it has a few specific quirks worth knowing about. Let me start with the opposite direction pattern. Imagine a sorted array and a target sum. You want to find two elements that add up to the target. Brute force checks every pair. That is n choose two combinations, roughly n squared. With two pointers, you place one index at position 0 and another at the last position. Add the two elements. If the sum is less than the target, the left pointer moves right because you need a bigger number. If the sum is greater, the right pointer moves left because you need a smaller number. If they match, you are done. Each step eliminates at least one candidate position, so you finish in at most n steps. In Rust, this looks like a while loop with low and high as usize indices, using match on the CMP result of the sum versus the target. The match arms handle equal, less, and greater exhaustively, which is nice because the compiler checks you covered all cases. Now here is the first Rust gotcha. When you initialize high as nums.len-1, that subtraction panics if the slice is empty. Usize is unsigned, so 0-1 is not -1. It is either a panic in debug mode or a wrap to the maximum usize value in release. You must check that the slice has at least two elements before subtracting. An early return with none is the cleanest way to handle this. Alternatively, you can use saturating sub, which clamps to 0 instead of panicking, but you need to make sure your while condition still handles that correctly. The second pattern is same direction, also called slow and fast pointers. Both start on the left side. The fast pointer scans forward looking for elements that meet some condition. When it finds one, the slow pointer marks where to write it, then advances. This is the standard approach for removing duplicates from a sorted array in place. Here's how it works. Slow starts at 0. Fast starts at 1. When nums at fast differs from nums at slow, you increment slow and copy the value over. At the end, slow plus 1 is the count of unique elements. The key insight is that everything to the left of slow inclusive is the deduplicated prefix, and you never look back. In Rust, you are working with a mutable slice reference. You might think about using iterators here, but you need to write to one position while reading from another. Two mutable references into the same slice violates Rust's aliasing rules. The borrow checker rejects it at compile time, 3:30 to 4:30. Let me show you a third problem that uses opposite direction pointers. Container with most water, leak code 11. You have bars of varying heights and want to find two that hold the most water between them. The area is the minimum of the two heights times the distance between them. Start with the widest container, pointers at both ends. Then always move the shorter side inward. Why? Because the area depends on the minimum height. If you move the taller side, the minimum cannot increase. It can only stay the same or decrease. And the width always shrinks by 1. So moving the taller side guarantees a worse or equal result. Moving the shorter side at least has a chance of finding a taller bar that compensates for the lost width. The code is a while loop tracking the best area seen so far. 4:30 to 5:15, one more Rust-specific thing. If you genuinely need two mutable references into different parts of a slice, the standard library gives you split at mut. You pass an index and get back two non-overlapping mutable slices. The compiler is happy because aliasing is impossible by construction. But honestly, for almost all two-pointer interview problems, plain index access is simpler and clearer. Save split at mut for when you are doing something like swapping elements at known positions and want to be explicit about it. Quick summary of when two pointers works versus when it does not. You need some form of ordering or monotonicity to decide which pointer to move. Sorted arrays give you that. If the array is unsorted and there is no monotonic property, a hash map is probably the right tool. Also, two pointers finds pairs. For triplets, you fix one element with a loop and run two pointers on the rest. That is the threesome pattern, O of n squared total, which is optimal. Tomorrow is day 9, sliding window patterns. Sliding window is really just same direction two pointers where you track an aggregate between the pointers. If today clicked, tomorrow will feel like a natural next step. See you then.